Hello everyone, I am Dr. Alok Agrawal and I will be taking your course Fluid Mechanics with course code ME404. So in last video we have seen what is viscosity, what are Newton's law of viscosity and Newtonian and non-Newtonian fluid, and we have also seen the various types of fluid. In this class we will extend further and we will see some numericals related to the viscosity. So let us start with our lecture 4, that is numericals on viscosity. So the first problem is if the velocity distribution over a plate is given by u is equal to 2 by 3 y minus y square, in which u is the velocity in meter per second at a distance y meter above the plate. So here the velocity profile is given. कि how velocity is changing with respect to y. ये u is equal to 2 by 3 y minus y square जो दिया हुआ है, ये y के रिस्पेक्ट में वेलोसिटी कैसे चेंज हो रही है, इसका एक इक्वेशन दिया है, एक प्रोफाइल दिया है, इसको बोलते हैं वेलोसिटी प्रोफाइल. अब यहाँ पे u जो है वो मीटर पर सेकंड में है और जो y है दैट इज इन मीटर, सो इट इज इन अवर SI यूनिट. What we have to determine? We have to determine the shear stress at two different points, that is at y equal to 0, which means at the plate, and second at y is equal to 0.15 meter, that is at a distance of 0.15 meter from the plate. The dynamic viscosity of fluid is given as 8.63 poise. So poise is the CGS unit of viscosity. So we have to convert this CGS unit into SI unit as I discussed earlier. And we have also seen the relationship between the SI and CGS unit. Okay. So this is our problem. So let us start. We know what is Newton's law of viscosity. Newton's law of viscosity is tau is equal to mu du by dy. Okay. So what we require here? We require du by dy, because tau is equal to mu du by dy, where mu is viscosity, tau is shear stress, and du by dy is velocity gradient. So here u is given, but we require du by dy. First we have to differentiate this with respect to y. इसको हमको differentiate करना. So du by dy is equal to 2 by 3 minus 2y we get after differentiation. Now we have to determine shear stress at two different points, at y is equal to 0 and at y is equal to 0.15 meter. So we have to calculate the value of du by dy at y is equal to 0 and y is equal to 1.5 meter. So du by dy at y is equal to 0, we have to put 0 in place of y and we get 2 by 3, that is 0.667. Similarly, at y is equal to 0.15, we have to put y value as 0.15 and we get du by dy at y is equal to 0.15 is 0.367. So we get two different velocity gradient at two different locations. Now mu is given 8.63 points, so we have to divide it by 10 to convert it into the SI unit, that is 0.863 न्यूटन सेकेंड पर मीटर स्क्वायर. तो इसको हमने SI यूनिट में कन्वर्ट कर दिया, क्योंकि हमारा यहाँ पे मीटर पर सेकेंड में वेलोसिटी, डिस्टेंस मीटर में, so we have to convert this viscosity also in SI unit. Now shear stress as y is equal to 0, we are applying Newton's law of viscosity, that is tau is equal to mu du by dy at y is equal to 0. We have to multiply mu by du by dy, that is 0.667. We get shear stress at the wall, that is y is equal to 0. Similarly, at y is equal to 15, we have to use du by dy at y is equal to 15, that is 0.367 value, and when we put this value we get 0.1367 Newton per meter square as our shear stress at a distance 0.15 meter from plate. So this is very simple numerical, and it is important because here we can see that how we can change the velocity profile into velocity gradient by differentiating it with respect to distance and how the things work. Now let us move to the second problem. Here it is given a cubical block weighing 4.5 Newton and having 40 centimeter edge is allowed to slide down on an inclined plane surface making an angle 30 degree with the horizontal, on which there is a uniform layer of oil 0.005 centimeter thick. So a lot of things are given here. There is a cubical block whose weight is 4.5 Newton, having dimension 40 centimeter. It is allowed to slide down on an inclined plane. So see, this is the condition. Here there is an inclined plane making an angle 30 degree. The weight of the cubical block is 4.5 Newton. Okay, and it is given, just a minute. Okay, so there is a cubical block 4.5 Newton, edge length 40 centimeter, angle of inclination 30 degree, thickness of the layer between the cubical block and the inclined plane is 0.005 centimeter. That is when we have to convert it in meter. Then velocity of block u is equal to 12.5 centimeter is given, that is 0.125 meter. So let us draw the figure how it will look like. This is the inclined. Let me do one thing. Okay. This is the inclined plane. Okay. This is the inclined plane, and there is a cubical block on it, which is inclined. This is not inclined, but when we make it, it will be like this. So let us make it like this. Okay, there is a cubical block, and this is the inclined plane. This inclined plane is making angle 30 degree. ये है जो है it is 30 degree. Yeah, this angle is 30 degree. Now this block is sliding downwards. Its weight is acting downward, that is 4.5 Newton. It is always acting downward. Okay. Edge length, this length is given 40 centimeter. So for cube, every side is 40 centimeter. Angle of inclination is 30 degree. And the space between this block and this inclined plane is dy, which is given 0.005 centimeter. We have to convert this in meter. Now this block is sliding, and this block is sliding with a velocity 12.5 centimeter. Okay, so with the velocity 12.5 centimeter per second, and we have to convert this centimeter per second into meter per second. Okay, now again the density of fluid which is in between this block and this inclined plane, it is given 800 kg per meter. So a lot of things are given. We have to calculate what? First we have to calculate the viscosity of the oil, because viscosity is not given, and next we have to calculate the kinematic viscosity in Stokes, and density of oil is given. So let us start. Okay, so here the weight is acting downward, so this has two components. One is along the plane and another one is perpendicular to the plane. So see, there are two components. One is this one and another one is perpendicular to the plane. So which component is making this block to slide? ये block किस component के कारण slide हो रहा है? This block is sliding. See, this is angle theta. If this is 30 degree, then this angle is 30 degree. Okay, so this will be the cos component. This will be the cos component, and this will be the sine. Sorry, sine component. W sine, and this one will W cos. If you take this angle as alpha, this is W cos alpha and this is W sin alpha. तो ये जो एंगल इसके कारण ये ब्लॉक नीचे स्लाइड कर रहा है, वो W cos alpha के कारण नहीं कर रहा है, वो W sin alpha के कारण कर रहा है. So here weight is given W, but cannot take weight W directly here because it is making angle, and we have to take the component of W which is because of which this block is sliding. Okay, so we have taken component of weight of block along the plane which is W sine alpha. Now we have Newton's law of viscosity, that is tau is equal to mu du by dy. This tau is shearing stress. Okay, so we have to calculate shearing force. So what we have to do, we have to convert this stress into force, that is F by A, and when we put in place of this tau F by A will come here and multiply, so we get shearing force as mu is equal to U by V into A. Now force we know, because of what force? The block is sliding, weight of the block along the plane, that is W sin alpha we will put here, mu U by Y into A. Okay, now what is the known thing here? Here we know W weight, which is given 4.5 Newton, alpha is known, mu we have to calculate, U is given 0.215 meter per second, Y is given, that is 0.0005 meter, and area of block is What will be the area? Because edge length is given 40 centimeter, we have to convert this 40 centimeter into meter, and then it is a, if you look from the top, it will look like a square. ये कैसा दिखेगा? स्क्वायर. जो चीज ऑयल के कांटेक्ट में आ रही है वो एरिया लेना है हमको. तो कौन सा पोर्शन ऑयल के कांटेक्ट में आ रहा है? जो नीचे एक स्क्वायर रहेगा क्यूब का, वो एरिया ऑयल के कांटेक्ट में आ रहा है. तो शेयरिंग वहीं पे होगी, तो हमको वही एरिया लेना है, दैट इज 0.4 इंटू 0.4 जो लिया हुआ है. ठीक. तो यहाँ से हम सबको एक तरफ रखेंगे, म्यू को एक तरफ रखेंगे, तो डब्ल्यू साइन अल्फा इंटू वाई बाई यू उल्टा हो जाएगा, इंटू divided by a. So we'll get this, and finally when we calculate this, we'll get mu is equal to 0.0056 Newton second per meter square, or we can say it 0.056 points. Okay. Now kinematic viscosity, we know kinematic viscosity is dynamic viscosity divided by rho. Simple formula. यहाँ पे काइनेमेटिक इसको डायनेमिक विस्कोसिटी की वैल्यू रखेंगे, लेकिन अगेन हम किस में रख रहे हैं? इसको हम रख रहे हैं एसआई यूनिट में, और क्योंकि यहाँ पे डेंसिटी भी हमारी एसआई यूनिट में. So when we calculate it, we get 7 into 10 to the power minus 6 meter square per second. Now we have to convert this in Stokes because it is given, and we also know the relationship between the SI and CGS unit of kinematic viscosity. We have to multiply with 10 to the power 4 to convert this meter square per second into centimeter square per second. So we'll get finally 7 into 10 to the power minus 2 Stokes. So this is the second numerical, which is very important because it has been asked in the exam previously. Uh, Let me clear it. Okay. Now let us move to the third problem. This is again very important problem, and it's asked 2 to 3 times in university examination. So let us see the problem. In a 50 long general bearing arrangement, clearance between the two concentric condition is 0.1 mm. Means there is a general bearing arrangement which is a 50 centimeter 50 long, and the clearance between the two is 0.1 mm. The diameter of the shaft is given 20 and it rotates at 3000 rpm, and the dynamic viscosity of the lubricant is 0.01 pascal second. Here pascal means newton second per meter square. Okay, so it is given in SI unit, and the velocity variation in the lubricant is linear, means we can apply here Newton's law of viscosity. Again, considering a lubricant to be Newtonian, calculate the frictional torque the journal has to overcome and the corresponding power. So let us see the arrangement first. So here there is a shaft of diameter 20 Okay. Now this is the arrangement. The clearance of 0.1 is given. The length is 50 is given. 50 long journal bearing. Okay. So this bearing is rotating at a speed of 3000 rpm. Okay, and while rotating there is a lubricant between these two at a clearance of 0.1 and when it will rotate, it will experience shear force, shear stress, because here this portion is stationary and this portion is rotating. तो the oil which is in contact with this, यहाँ के contact में जो oil रहेगा वो stationary रहेगा, और इसके contact में जो oil रहेगा वो इसके speed के साथ move करेगा. So there will be a development of shear stress between the oil layer in between the clearance. So first of all, let us write the given length is given, clearance is given, diameter is given, speed is given, viscosity. We have to convert all the things in SI unit, that is in meter. Now from the Newton's law of viscosity, we have tau is equal to mu du by dy, or we can say it u by t. Here we are using u, and t is the thickness of the oil. That's why we have converted dy into t. Now viscous shear stress is converted into shear force by multiplying this by area. What will be the area here in this case? The curved surface area of the bearing, because oil is in contact with the curved surface area of the bearing. वो पूरा का पूरा एक सिलेंडर से ऑयल को घिरा हुआ है. ठीक है, ऑयल से घिरा हुआ है वो सिलेंडर. तो जो स्ट्रेस लगेगा वो उसके उतने सरफेस में लगेगा जो वो ऑयल के कांटेक्ट में आ रहा है. तो ऑयल के कांटेक्ट में कितना आ रहा है? पूरा सरफेस, कर्व सरफेस एरिया. अब कर्व सरफेस एरिया क्या होता है सिलेंडर का? 2 pi r into L. So here we are taking area as 2 pi r into L. Now we have force. So what will be the torque? Torque will be the force into distance. So it is rotating about its center. This shaft is rotating about its center. So what will be the arm length or torque arm? D by 2, that is radius. So viscous torque will be viscous force, that is u mu into u by t 2 pi r L into r. Okay, so from here we can calculate torque, but we don't know the u because this is the rotational speed. What is given to 3000 rpm is rotational speed. We have to convert this in linear velocity because in formula we are using linear velocity. So converting it to linear velocity using formula pi d n by 60, d is diameter and is rotational speed, we get 3.14 meter per second as our linear velocity. So substituting all the value in this equation, we get frictional torque as 9.85 into 10 to the power minus 3 Newton meter. Now we get frictional torque, what is been asked. Now we have to calculate the corresponding power loss. So power loss is T into omega. Omega is angular velocity. So first we have to calculate angular velocity, that is 2 pi n by 60. This is the formula that you have already seen in your previous semester. So this omega is 314 radian per second, and when we put the power loss P is equal to T omega, we will get 3.09 watt as our power loss. So this is a very important numerical. You have to practice it multiple times to get acquainted with this. So let us move to our last numerical of the video, that is a flat plate 0.3 meter square in area move edgewise through oil between large fixed parallel plane 10 centimeter apart. If the velocity of plate is given and the kinematic viscosity of oil is given along with specific gravity, we have to calculate the drag force. Now there are two conditions. One, in first condition, the plate is equidistant between the two parallel plates, and in second condition, the plate is at a distance of 2.5 centimeter from one of the plates. So this is interesting problem. So let us start with case one, when this moving plate is at equidistance between the two parallel plates. So it is at the center. That is, if the distance between the two parallel plates are 10 centimeter, then this plate is moving at a distance of 5 centimeter from each plate. Okay, so let us write first given condition. Area of the thin plate is given. This area means upper area and lower area, both area. Because in this case, the plate is in contact with oil above also and oil below also. So we have to calculate tau 1 and tau 2 both here. Okay, in previous problems it is not the case. The body is in contact with one plane only with the oil. Now here the body is in contact with both sides with the oil. So distance between the two fixed plates is 10 centimeter. Velocity of thin plate is 0.6 meter per second. Kinematic here, dynamic viscosity is not given. But we know that in Newton's law of viscosity, we have to put dynamic viscosity. But here kinematic viscosity and specific gravity of oil is given. And with the help of this two, we have to calculate the dynamic viscosity. इन दोनों की मदद से हमें dynamic viscosity निकालनी पड़ेगी. Because we know that kinematic viscosity is the ratio of dynamic viscosity and density. And density is calculated with the help of specific gravity of the oil. इस specific gravity of oil से हम सबसे पहले density निकालेंगे. Density को काइनेमेटिक विस्कोसिटी से मल्टीप्लाई करेंगे तो हमको क्या मिल जाएगा, डायनामिक विस्कोसिटी. तो हमारा केस वन क्या है, व्हेन द थिन प्लेस इज इन मिडिल ऑफ द टू प्लेन सरफेस. So let F1 is the shear force. If the plate is moving in from left to right, the shear force will act in the opposite direction. Shear force F1 in the upper side of the plate and F2 is the lower side of the plate. So total shear force will be F1 plus F2. Now first we have to calculate the dynamic viscosity. Mu is equal to V into rho, and rho is specific gravity into 1000, because we know specific gravity is density of unknown liquid upon density of standard fluid, that is water, and water density is 1000. When we substitute this value, we get dynamic viscosity at 0.036 Newton second per meter square. Now we have to calculate shear force, because here drag force is given, means shear force, but we have the formula of shear stress, tau 1 is equal to mu du by dy. So tau 1 we get after substituting the value, tau 1 is equal to mu is just we have calculated, du is the velocity of the plate, and dy is the distance from the fixed parallel plane. So for upper side it is centimeter, so we are writing here 0.05 and we get 0.432 Newton per meter square as our shear stress at the upper edge. Now we have to calculate shear force, so we have to multiply this shear stress with area. So multiplying this shear stress with area is given 0.3 meter square. So we get F1 as 0.1296 Newton. On a similar note, we have to calculate F2, and this plate is at equidistance from both the parallel planes. So here in case 1, F2 will again be same, that is 0.1296 Newton. Now the total drag force will be the F1 plus F2, which is coming out to be 0.2592 Newton. तो दिस इज केस वन व्हेन द प्लेट इज एट द मिडिल। अब हम देखेंगे कि भैया ये प्लेट अगर पोजीशन अपनी चेंज करती है तो whether the force will remain same or it will change. Let us see. Second case is when the plate is at a distance 2.5 centimeter from the one parallel plane. So we have taken 2.5 centimeter distance from the upper parallel plane. Okay. So ये प्लेट अब ऊपर वाले प्लेन से 2.5 सेंटीमीटर हो जाएगी और नीचे वाले प्लेन से 7.5 सेंटीमीटर हो जाएगी बिकॉज द डिस्टेंस बिटवीन द टू प्लेट इज फिक्स्ड दैट इज 10 सेंटीमीटर. Okay. So it is 7.5 centimeter, that is 0.075 meter. Again, the formula will remain same. First, we have to calculate tau 1, but here dy will be changed. पहले dy था 0.05 दोनों केस के लिए, अब पहले केस के लिए इधर के लिए dy हो गया हमारा 0.075 और जब हमने इसको रखा तो हमारा shear stress आया 0.288 और उसको फिर एरिया से मल्टीप्लाई किया 0.3 से तो हमारा F1 आ गया, इसको F1 ले रहे हैं इस केस में, ठीक, तो 0.0864 न्यूटन आ गया. नाउ F2 निकालने के लिए हमको टाउ टू निकालना पड़ेगा. टाउ टू के लिए हमारा डी वाई टू आ जाएगा 0.025 सेंटीमीटर. यहाँ पे F1 F2 उल्टा लिखा गया, ये F1 रहेगा ये F2 रहेगा, कोई बात नहीं. तो 0.036 into this one and we get tau 2 as 0.864 and after multiplying it with the area we get F2 is 0.259. So what will happen now? We have to add this F1 and F2 to get the total drag force and it is 0.3456. तो देखिए यहाँ पे हमारे को जो टोटल ड्रैग फोर्स अलग मिला, केस वन से अलग मिला, मतलब जैसे जैसे प्लेट की पोजीशन चेंज हो जाएगी हमारा ड्रैग फोर्स भी, शियर स्ट्रेस भी चेंज होता है. तो दिस इज अगेन वेरी इंपॉर्टेंट प्रॉब्लम. इसमें हमको बहुत सारी चीजें देखने को मिली कि किस तरह से इफेक्ट होता है और अगर हमारा जो बॉडी है वो चारों तरफ से अगर घिरा हुआ है, अगर वो चारों तरफ से घिरा हुआ है तो क्या होगा, हमको उस हिसाब से एरिया लेना पड़ेगा. एरिया क्या होता है कि कितना पोर्शन, कौन कौन सा फेस हमारा अ, जो हमारा लिक्विड है उससे सराउंड. तो यहाँ पे हमने थिकनेस नेग्लिजिबल मानी तो सामने वाला और पीछे वाला साइड नहीं लिया, बस ऊपर वाला और नीचे वाला साइड. ठीक है. तो दिस आर द फोर इंपॉर्टेंट न्यूमेरिकल्स टू विस्कोसिटी. थैंक यू वेरी मच.